I'm going to talk about ACID transactions on Presto tables. But first, I'm going to introduce what we do in Datorama and why we need that to begin with. Sorry. So Datorama was founded 7 years ago. We have a pretty solid customer base with names like Spotify, Disney. So what is Datorama? Datorama is a data marketing intelligence platform. What's that? You know, nowadays, a marketing campaign usually spans dozens of marketing vendors. You know, stuff like Google AdWords, Facebook ads. But how do you make sense of all this data? It sits in dozens of places, sits in different formats. And that's exactly the problem that we're solving. We bring your data from all the sources to one place, bring it to some common structure, and act as a single source of truth. You know, some place where you can compare your campaigns among Facebook and Google. So that's how the workday of market analyst looks with and without using Datorama. So if without, most of the time spent on stuff like downloading Excels, figuring out how to unify all this data, we solve this problem. Most of the time is actually spent doing stuff they're good at. Okay, that's a totally cool example. Metallica are using Datorama for their marketing efforts. And this dashboard is actually pretty easy to do in our platform. You just enter your credentials for Facebook, Instagram, Twitter, drop a bunch of widgets, standard widgets to your dashboard, and that's it. You're good to go. Even a not very technical person can start analyzing why they're good in Sweden and pretty bad in France. Some scale numbers. We've got a couple petabytes of compressed data sitting in storage. It's not actually just sitting there. It's constantly hammered by analytical queries. We've got several millions of interactive analytical queries. Analytical queries means these queries don't just bring a couple of rows. They process thousands, millions, or even billions of rows. And interactive means that some guy, maybe a guy from Metallica, is actually sitting and waiting for the dashboard to load. So it needs to be fast. Okay, as I said, we've been acquired for almost $1 billion by Salesforce. So that means that all these numbers from the previous slide are actually going to explode. You know, our VP is sitting here, he asks us how we do make it, to support 100 times growth. Okay, so we're arriving to data lake. Customers are no longer satisfied with just aggregated data they get from Google AdWords. They have a bunch of data, raw data in-house, and they want to process it together. And that's almost the definition of data lake. Some place where you can just pour all your data and process it. But managing data lake is a huge pain. Okay. So Datorama is going to provide data lake as a service. Some service where we can just take all your data from all your marketing vendors from your S3, keep it in our services, and analyze it. The problem is that this data is not final. Statistics you get from AdWords are not final. They're up to update. And if we're talking about the raw data, customers just enjoy updating it. But most of the big data solutions are actually for static data or append-only data. And the update is treated like a maintenance event. It's done over a weekend, or you get a Slack message, guys, avoid touching this table. We're updating it. And we can't afford that because we provide the service. So customers expect this data to be constantly available. So that's actually what it means, transactional updates. Updates need not interfere with queries, and queries need to always bring consistent results. Finally, we're getting technical. What are the requirements of our technical solution? Okay, first, separate compute and storage, hot topic for pretty while. basically keeping your data in local disks of the database limits your scalability. It needs to be fast. Remember the guy sitting in front of the dashboard. We want standard SQL because we have a pretty cool, query engine, and we want to leverage that. And we want to provide external direct access to this data by JDBC. Transactional we've talked about. We don't want to be dependent on some cloud vendors, so stuff like Redshift is out. And of course, linear scale. You know, Christmas is coming. Marketers are on the craze. We want to accommodate that. So actually, if we keep this data in cloud storage and query it by Presto, almost immediately satisfies most of the requirements. We just need to be somewhat creative about this transactional point. So let's see at the flow of the update. So our table is sitting in storage, partitioned by some key, probably date. And there's the chunk of data coming in, chunk of update data, C. So first, we parse this data to figure out what partitions of the current table are affected. So in this case, we see that A and B are affected, and it actually starts a new partition C. First thing, we read the relevant partitions from the storage, process it, update it, store to new location, A star, B star, C star, and we need to somehow swap the partitions AB, old AB, with the new ones. And we don't want just to delete the old partitions yet, because currently running queries need to somehow finish successfully. Now the tricky point is that this partition swap needs to be transactional. What does it mean? We can't just drop the old partition before we add the new one, because query will be missing data. Or the opposite, we can't add the new one before dropping the previous, because query will see duplicated rows. And if that sounds not too complicated, this change needs to happen atomically between all the partitions involved and all the tables. A bit about our architecture. We use microservices architecture. ETL and query are not talking directly. ETL just preparing data for it. So there's an update request coming in the queue. We use Rabbit. First, it goes through a resource manager. It does a bunch of stuff, but basically just protects from the table being updated simultaneously. ETL uses Spark to read the data from storage, update it. It prepares data in Hive so Presto can use it. And it changed this something we call metastore. I'll be talking about it in the next slide. Just keep in mind that this is the actual key to this process being transactional. OK. This stuff is a little bit tricky, so I want you to pay attention. We partition the table by a key version field. You like it, huh? So the key is the actual value stored in this partition. And version is some incremental number, you know, in the sense of optimistic locking or something like that. Note that we don't partition the table by the date field itself. So actually, Hive and Presto are not aware that this partition holds this particular date. And why is it so? Actually, it allows us to keep both versions in the table at the same time. And at the query time, we can decide which version to use. So if we run select from table where version equals 9, it brings the old data. Version equals 10, it brings the new data. I hope you can feel this atomic transition, because by switching only one number, we flip the data. But let's go on. We create a table holding all active versions of all the partitions in our system. and we hold it in some transactional database like Postgres. So, okay, and we put this ugly clause in the SQL. What it actually means? It means that your query takes all the versions defined in this table, in this metastore table. And this is always up to date. And the fact that it's seized in transactional database means that we can alter all the versions atomically. Actually, from the point of atomicity, we actually solved the deal. We've managed to turn append-only operations into actual atomic acid transactions. Unfortunately, it doesn't work. And there are a couple of problems which eventually prevented it from reaching production. First problem, and actually David talked about something connected, it would probably solve this issue. Presto treats this SQL as a join between the actual table and the metastore table on the version field. And it starts fetching both tables simultaneously and eliminate it at the row level. But that's not what we actually wanted to do. It now scans the whole table. And we want to scan only the relevant partition to this date filter. So eventually it will give the right result, but the performance was atrocious. Another problem, think if there are two tables participating in this query. Each one has its own version clause. It means that Presto needs to issue two queries to Postgres. And if there's an update in between, they might get inconsistent snapshots of the versions. So yeah. But we're not giving up just yet. That's the next solution. So we can just fetch all the active version before the query. That solves actually both of these problems. First, Presto will scan only the relevant partitions. Second, we can fetch both tables in a consistent way. And actually, this is the solution that is running in our production for a couple of years. It's also not without problems. The point that we want to provide our customers with direct SQL access. And how do you tell them that before running the query, they need to do something, some maybe REST call or maybe SQL to some another database to fetch this data? There's no way they're going to do it. And actually, we kind of somehow managed to ditch this requirement for a couple of years. But now Salesforce put an emphasis on it, so we need to somehow solve it. So, what is it what we really want? We want alter table and Hive to be transactional. We want to do something like begin, alter table draw partition, alter table add partition, do it for all the partitions, commit, boom. It should work. And actually, if you think, Hive is storing its metadata in some transactional place in MySQL. So there's no reason why it wouldn't be able to do that. And that's our solution we're working on now. What we do actually, we reverse engineer in Hive to emulate alter table directly on the MySQL tables. It's ugly. It's not pretty. We become dependent on the Hive version. But it's our problems. From the point of view of service we provide to customers, it runs fast. The SQL is clean. All the problems solved. So a couple of back thoughts. We've managed to satisfy all of our requirements. we eventually moved from Parquet to RC, and before storing, we just store the data. So it helps RC, it helps Presto just skip most of the data. And yeah, everybody is happy, except for the guy who is reverse engineering Hive, and he is there. Yeah. So if you guys think that what we do is interesting, maybe you have actually a better idea, come join us. Thanks.